Hi guys, here's another friction problem, and maybe the first thing that jumps out at you is the fact that we've got a non-circular cross-section instead of a round pipe. So we will pretty much tackle this the same way as what we were doing before, only now instead of a diameter we use a hydraulic radius. So wherever we see a D in a formula, we know that D is equal to 4R from our previous notes. So wherever you see a D, put in the 4R. So, horizontal duct 50 meters long and carries ethylene glycol at 25 degrees Celsius through the shaded area. Volume flow rate is Q, is 0.16 cubic meters per second, and then we've got a roughness of 3 times 10 to the minus 5. What is the pressure drop over the length of duct? So, a typical start for me, as usual, is to get all the information I can about the fluid. So it says that we've got ethylene glycol at 25 degrees Celsius. So we've got a special table for that, which is Appendix B. You'll note that properties of common liquid at 25 degrees Celsius. So we can't use it for everything, but we can use it for ethylene glycol. There's our values. You can take them straight off and log them in here. First thing we will do is then take our hydraulic radius, and I've actually completed this already because in previous take the camera froze and I had this much done. But to recap, we know that the area is this flow area is this dark area here, so it's the area of the square minus the area of the circle. So 0.25 squared minus pi over 4, 0.15 squared will give us our area, and the wetted perimeter is 1, 2, 3, 4 of those sides times 0.25 meters, plus, don't forget plus, not minus, the circumference of that outer circle, pi d, to give us 1.47 meters, and our hydraulic radius of 0.035 meters. So, where I left off was, I was just saying that we also want to consider the side view here, because this is really what's going on. So the side view is we've got 50 meters long of this ductwork, and this is the cross-sectional area, looks like it. Point 1 and point 2, 50 meters in between them. What is the pressure drop between those 2 points? So that's our point 1 and point 2. I was just setting up our energy equation like so, and I had made the note that since the cross-sectional area is the same all the way across, we know that A1 V1 is equal to A2 V2, so V1 and V2 cancel out. Also, horizontal, so we know that Z1 and Z2 cancel out. And we also know that between point 1 and point 2, there are no devices adding or removing energy, so we can say HA is gone, HR is gone, and that will leave us with, after a little bit of arithmetic, P1 minus P2 is equal to gamma HL, and I'll just call that equation 1. Now, we're going to need velocity, so I'll just do that quickly over here. V is Q over A, so 0.16 divided by, the area was calculated over here as 0.0448 square meters, and I get a velocity of 3.57 meters per second. So, let's get our Reynolds number to see what type of flow we're dealing with. Reynolds number is equal to rho V, and instead of D, we put in 4R, and over mu. Now, you could use Reynolds number is VD over nu if you like, but we used this one in the last problem, so why not use this one here now? So, 1100, 3.57, and then 4 times 0.0305, and our nu, our dynamic viscosity, is 1.62 times 10 to the minus 2. That will give us a Reynolds number of 3.0 times 10 to the 4. And no dimensions there, or should I say dimensionless. And you might recall that we said for greater than 4,000 in a round pipe, that's considered turbulent. We don't have anything in particular for this shape, but suffice it to say that whenever we get up around 30,000 for a Reynolds number, no matter what the shape, we can feel pretty sure that we're dealing with turbulent flow. So we know to get friction, because we have turbulent flow, we've got to use the Darcy-Weisbach equation, and we've got to get our F value from our Moody diagram, or Swami chain, but we want some practice with the Moody. So in order to use the Moody diagram, we need a Reynolds number, and we also need a d over epsilon. But don't forget, that's now 4r over epsilon. We found that d equals 4r earlier on in our notes. You can check that derivation if you don't recall. But let's plug in our numbers. 4 times 0.0305. Epsilon was given to us up here as 3 times 10 to the minus 5. And those, of course, are both meters. And that gives us a value of 4,067. So now we go to our Moody diagram. So we want 3 times 10 to the 4 for our Moody diagram. Let me get in the page here. So 3 times 10 to the 4, there's 10 to the 4. 3 times 10 to the 4 is right here. So now we want to go upward, and difficult to see here, but we actually don't have a line, no surprise, for 4,067, but we do have one for 5,000, so we know we're going to be close to that. So let's follow our 5,000 line up, and we see that it does stop a little before we get to where we want to go. So we just continue on. For me, I look and I say it's halfway in between that 2,000 and the smooth pipeline. So I'm just going to continue to go halfway between 2 and the smooth pipeline. And I'm going to say that I'm just going to be on this line, maybe a little bit below, but I'm going to go with that line right there. And I'm going to read across, and I have got this spot right here, which I've got 0.024. So 3 times 10 to the 4, read up to approximately 4,000. Now again, just do your best. I mean, a little bit below is fine. A little bit above is probably too far. Definitely don't go below the smooth pipeline. So let's go with F is equal to 0.024 from the Moody diagram. Now, finally, we can go HL is FL over, now instead of D, we've got 4R, V squared over 2G, 0.024. Our length was given as 50 meters. 4 times the hydraulic radius, 0.0305 meters. Velocity was 3.57. Don't forget to square. Divide by 2G. And that should give us an HL of 6.49 meters. And so now we can return to equation 1. So we can say P1 minus P2 is gamma HL. Don't forget we have a specific gravity of 1.1 multiplied by 9810 multiplied by our HL, 6.49. That gives a pressure drop of 70.4 times 10 to the 3 pascals. Okay? Just like the other ones, only the difference is wherever you saw a D, plug in a 4R. Hopefully this works for you. Thanks.